Hey everyone, welcome to the back side of the 4.55.2 notes. So we were adding, subtracting, and multiplying radicals. Again, 5.2 notes. We did the front side in the previous video. Let's talk about the back side. So I've got four examples for you here, and you'll notice at the top it says binomials. So this is going to be the same idea as multiplying on the front side, except for there's a few extra steps. Everybody's favorite thing, I know. What the difference is between when it's a binomial and the front side, we would call those monomials, is there are two terms inside the parentheses. Two means bi, that's why it's binomials. And basically, you need to FOIL or distribute. So, for example, on this first one, we're going to multiply that together. And when you're doing this, just don't freak out. Take it one step at a time. So, there is a 1 out front if you want to put it there. 1 times 5 is 5. And then you can multiply the numbers inside the square root. 5 times 10 is 50. Then you're going to do the next one, taking it again one step at a time. The numbers out front, you should always do those first since you write them first. 1 times negative 2 is negative 2. And inside 2 times 10 is 20. And then you do need to simplify both of these square roots. So you're looking for a perfect square that goes into 50 and a perfect square that goes into 20. Perfect squares, as a reminder, are 4, 9, 16, 25, 36, and so on. That's where I'm going to stop because my biggest number right now is 50. So 50 ends up being not 4, 4 doesn't go into 50, 9 doesn't go into 50, 16 doesn't go into 50, especially if 4 didn't already, and 25 does. Then you're going to actually do the square root of 25. So one thing that I think a couple people have been confused about is that square root is still there right now. It doesn't get to go away until we say, oh, 5 to the second power is 25, so we can actually put a 5 out front right here. And then that 5 gets multiplied by the 5 that was already out there, which makes this 25 square roots of 2. So the 2 has to stay inside because there is no square root of 2. And then over here with the 20, it ends up being 4 times 5. I'm pretty sure everybody's pretty familiar with the fact that 4 times 5 is 20. Square root of 4 is 2, so you get to pull a 2 out front. But it has to multiply by the negative 2 that was already out there, which is going to make negative 4. And then the 5 has to stay underneath. So really, we have 25 square roots of 2 minus 4 square roots of 5. That is not the same square root, so they cannot be added together. Bada bing, bada boom, there's your answer. On the next problem, you'll notice that instead of one set of parentheses, there are two sets of parentheses. This is where you're going to have to actually do what's called FOILing. That's just a fancy way of saying that this number in the beginning has to multiply to both of these. Don't freak out that there's going to be 4 things on this one. Just take it, again, one step at a time. 8 times the square root of, 8 times 3, there's no square roots here, that's what I was going to say, is just 24. It's just a regular multiplication problem. We've done it before, but now that we're doing it with radicals, people get a little freaked out. Then 8 times negative 1 square roots of 10, if you want to put it there. You're going to multiply the numbers out front. 8 times negative 1 is negative 8. And there's nothing to multiply the 10 by because there's nothing else in the square root here. So that's just the square root of 10. And then you're going to take this negative square root of 10 and multiply it by both of them. So negative 1 square roots of 10 times 3 is negative 3 square roots of 10. We're multiplying that negative 1 and the 3 out front. Since there's no other square root, the 10 has to stay the same. And then you're going to do negative square root of 10 times negative square root of 10. So you can multiply the numbers out front if you want. -1 times -1 is +1. I'm not going to write the 1 out front. And then you can multiply the numbers inside the square root, which in this case is 10 times 10, or 100. And then you have to go check to see what can be simplified. 24 is just 24. The square root of 10 can't be simplified any further, but these two are both square roots of 10. So I can combine -8 and -3 square roots of 10, which would make -11 square roots of 10. And then the square root of 100 is 10. That's 10 squared. So I can actually add together this 24 and 10 now that it doesn't have a square root anymore. And 24 plus 10 is 34. I would also accept -11 square roots of 10 plus 34 as an answer. It doesn't matter what order those go in. Although I will say that most people typically prefer for their square root to go at the very end, so they don't have to worry about where they stopped the top part. Like that 34 does not need to go underneath, and you need to make sure that that's clear as you write your answer. Okay, I'm going to pause right here and say one thing that's been asked a couple of times. When you are adding these two together, that square root does not change. When you are multiplying, the root part does not change. So if these are square roots in the beginning, they're going to be square roots for this whole problem, unless you can actually do the square root like on this one, where the whole square root actually got to go away. But a square root is never going to magically change into a cube root. A cube root is never magically going to change into a fourth root. So the little number that's supposed to go out here will never change. Like this one is imaginary 2. The number out front can change like these two, but not the index. The index of the radical can't magically change in a problem. All right, let's try 2 more just for more practice. We have 6 square roots of 6 times the square root of 6. Again, remember that we're just taking this one step at a time. You are multiplying the numbers out front first. That would be 6 times 1, which is 6. And then do the insides. 6 times 6 is 36. There are 2 ways of solving that one. The first way is the way that I just did it. The second way is noting that when you multiply a square root by itself, it's going to cancel, because the square root of 36 is just 6. So it's really supposed to be 6 times 6 without any radical left. And then I'm going to do 6 square roots of 6 times the square root of 2. I know these look complicated, guys, but if you follow my steps, it's super simple. The numbers outside, 6 times 1 is 6. And then multiply the numbers inside. 6 times 2 is 12. Then we need to split up 12 and try and simplify that square root. 12 is 4 times 3. The square root of 4 is 2. So that gets to come outside. And multiply by the 6 that's already out there, which makes 12 square roots of 3. Because the 3 does not have a square root. Then I'm going to take this -6 square roots of 2 and multiply it. Okay, numbers outside go first. -6 times 1 is -6. Insides, 2 times 6 is 12. Well, I just simplified the square root of 12. In fact, you'll notice that these two would have canceled out because they are opposite signs, but everything else about them is the same. But I'm going to go ahead and simplify it anyway because I had already done that with the first one. We already know that 12 is 4 times 3. That's going to make the square root of 4 2 on the outside. And that 2 needs to multiply by the -6 that's already there, making this -12 square roots of 3. So even after I simplify it, you can tell that these two are about to cancel out. And then I have one last multiplication to do here, the last one in each parentheses. -6 times 1 is -6. And then inside my radical, 2 times 2 is 4. Or note that when you multiply a square root by itself, it's just going to become that number but without the radical. Okay, so square root of 2 times the square root of 2 is 2 without a radical. Or it's the square root of 4 and the square root of 4 is 2. Same thing. A -6 times 2 is -12. Then I'm going to combine my like terms. 36 plus -12 is 24. And 12 square root of 3 minus 12 square root of 3 is 0. Look at that super nice answer to that really complicated problem. Crazy to think that this is another way of saying 24. All right, on the fourth one, make sure that whenever you see a binomial, meaning it has two terms squared, you have to write it like this. So you're just basically expanding it. Notice how I kind of crossed through the 2 as I did that. Then 4 times 4 is 16. 4 times the square root of 5, sorry, -1 square root of 5 is just going to be -4 square root of 5. 4 times -1 is your outsides, and it's only 1 square root, so the 5 has to stay there with the square root. And then -5 times 4, no, square root of 5 times 4. Oh. So when you multiply a square root by a number, that number just kind of goes in front like this. And then negative square root of 5 times negative square root of 5 is positive because you've got two negatives. And the square root of 5 times the square root of 5 cancels out the square root. Or 5 times 5 is 25, and then the square root of 25 is 5. There's two ways of doing that last part. Do whichever one makes more sense to your brain. And then I'm going to combine my like terms. 16 plus 5 is 21. And -4 square roots of 5 minus 4 square roots of 5 in the middle. That makes -8 square roots of 5. So when you have two square roots that are the same, these are both square roots of 5, you just add the numbers out front. -4 plus -4 is -8, but you don't change anything about the radical. Some of us are just trying to change a little more than we have to, and that's making it more confusing than it has to be. And then I threw this question at the end in there. I had given you guys a little bit of a hint that the last two problems on 5.1 homework are good candidates for extra credit on a test. This one is also a good candidate for extra credit on a test or quiz. So when you are finding perimeter, that just means you are adding all sides. So I'm going to go ahead and fill in all of my sides. Because remember, on a rectangle, the opposite sides are the same. And then I'm going to go through and add these little ones out front on anything that doesn't have them, just to make my life easier. And I'm going to go on the hunt for my numbers that don't have any square roots attached. 4 and 4, 8. Okay, I'm going to write that down in just a second. And then I'm going to go on the lookout for all of my square roots of 3. So I have 1 square root of 3 and 1 square root of 3. And then I'm going to go on the lookout for my square roots of 6. 7 square roots of 6, -1 square root of 6, 7 square root of 6, -1 square root of 6. So I'm just grouping these based off of what their square root is. So this is just going to be 8. This is going to add up to 2 of those square roots of 3's. And this is going to be 7 minus 1, which is 6. plus 7, which is 13, minus 1, which is 12. Yes, there are some ways you could group these together a little bit simpler. That's just how I chose to do it. And that is the perimeter of this shape. So really, I'm just combining like terms all the way around. You just have to make sure you include all 4 sides. Area is length times width. So the length of my rectangle, it does not matter which one you think is which, is 4 minus 1 square root of 6. The width is 7 square roots of 6 plus the 1 square root of 3. And you're going to multiply this out just the same way we did on the top. So I'm going to take 4 times 7 square root of 6. 4 times 7 is 28. The square root of 6 doesn't get to change because there's nothing else inside a square root. 4 times 1 square root of 3 is 4 square root of 3. So the 4 and 1 multiply since they are both outside. And then you're going to multiply these two. Don't freak out. I know there's a lot going on here. Just focus on outsides. Negative 1 times 7 is negative 7. And then insides. Square root of 6 times the square root of 6. Either make that the square root of 36, or realize that that's just going to cancel out the square root and it's just going to be 6. And then I have my last one, which is negative 1 square root of 6 times 1 square root of 3. Don't freak out, just do the outsides first. Negative 1 times 1, and 6 times 3. All right, now let's walk through simplifying this a little bit. I can't break up 6 anymore. It's going to have to stay. Can't break up 3 anymore. It's going to have to stay. Negative 7 times 6 is negative 42. So I'm going to cross it out and write it in front. And then negative 1 square root of 18. Well, 18 is 9 times 2. Again, you want one of them to be a perfect square. And then the square root of 9 is 3, which gets multiplied by the number that was already out there. So this is negative 3 square roots of 2. And I need to go check, is there anything else here that I can add it together with? No. So then I just have to list those all. And it doesn't really matter what order you choose. And I'm just going to kind of cheat. So that whole darn thing is here again.